Good evening, guys.
Good evening, ma'am.
Good evening.
Good evening. Uh, okay, let's wait for a few more minutes. Let's wait for other students to join and then we will start the session. Fine?
Yes, ma'am. Ma'am, I guess today there is OPP, so many students might not come, I guess.
Okay. Okay. So you're telling me to start the session or should we wait?
No,
What
no,
was
I'm just saying that there is OPP, so the
uh,
strength might be less.
might be less. Okay. So, okay, let's start the session then. I guess less students will be there. Yeah. Okay, so it is
Yes,
today's
ma'am.
week. Yeah, today is week 7. So have you guys gone through the lectures?
Yes, ma'am.
Okay. Were you able to understand week 7? What was it?
Yes, ma'am.
Mhm. Okay. So what was it about? Yeah.
It was about the real life practical uses of statistics which we have learned, applying them to samples of statistics.
Okay. Good. Yeah. Basically, somewhat that is the thing in week 7. Okay. So yeah, many students have joined. So let's start. Okay. So basically, what I would be doing, I have some questions like we used to do. But first of all, let's say the summarize the whole thing. What is it? Like the formulas and everything. Okay. So the first thing is what are IID samples? What do you mean by IID samples?
Independent and identical distributed sample.
Yeah, correct. So IID is basically what? Independent and identically distributed samples. So that means my samples should be independent of each other. So if I'm having an experiment, so in that experiment I would be having some samples, right? So that sample, so I'm having x1 as a sample, x2 as a sample, x3 as a sample, like that. So in total I'm having xn samples. So each of these samples should be independent and they should be identically distributed. Okay, so that's an IID sample. Then we have some descriptive statistics for empirical distribution, right? So what was the first one, which was sample mean, correct?
Yes, ma'am.
Yeah. So what is the sample? What is the formula of sample mean? Sample mean is basically x bar, which is the average of all the samples, right?
Yes, ma'am.
Okay. Now, what is the expectation of a sample mean?
Mu.
It is mu,
It
which
is
is
mu, correct.
original's
The,
expected value.
huh, which is equal to the original mean of the distribution. Then we have the variance of sample mean. What is the variance of sample mean?
Sigma
Sigma
square
square
upon n.
by n.
Okay, sigma square by n. So in this case, if my n increases, my variance of sample mean will be equal to what?
0, ma'am. It will tend
Correct,
to
Becoming
0.
zero. Becoming zero.
correct. So if my n is tends to infinite, so my variance of sample mean will tends to 0. Okay. Now we have third thing is sample variance. Okay. So what is the formula of sample variance? It is
Uh,
basically
it,
s
it is
square
equal
x1
x minus
minus
x bar divided by plus till xn divided by n
By
minus 1.
n minus 1.
by n minus 1. Okay. And the expectation of sample variance is equal to what?
Ma'am, it's in the lecture it's given that sigma square is given, but
Hmm.
but in in one of the tutorial, it's given some it is in relation with n actually. Uh,
Yeah.
one second, I'll just give you the formula, which was given
Uh-huh.
in the. It is n minus one into sigma square divided by n, ma'am. Actually, in one of the
This one.
tutorial, yes, ma'am. Week 7 tutorial 1, it's given at the last question.
This is not, I don't think so. That's an expectation. It is basically a relation between a sample variance, that is S square, and the sigma square. Basically, you know what is the sigma square? It is basically what? Summation of xi minus x bar whole square divided by n, correct?
Yes, ma'am.
Yeah, this is the thing. Then we have sample variance. Sample variance is basically what? Summation of xi minus x bar whole square divided by n minus 1, correct?
Yes, ma'am.
Now this thing is this numerator for both of them are same, correct? So in place of summation of xi minus x bar whole square in the population variance, I can write this as s square into n minus 1 in the place of numerator.
Yes,
Can I?
ma'am. Yes,
Yeah,
ma'am.
that's the thing. So this is the relation between the population variance and the sample variance. So basically, sigma square will be equal to n minus 1 sample variance divided by n. This is one relation. Okay.
Oh, okay, ma'am.
Hmm.
Ma'am, this is the relation between distribution variance and sample variance.
Correct.
Okay.
Okay.
Ma'am, if this is the
Now,
formula, then we can write in place of sigma squared the same thing, right? Because both are equal.
okay. So you are telling me expectation of so the expectation of this thing s square can be written as n into sigma square divided by n minus 1.
Uh, no, no. Ma'am,
This will be what?
we'll discuss in the doubt session. There is a question actually, or their proof is also given. Then they are stating that it is not equal. Expectation of s square is not equal to sigma square is also written at the end. Actually, that was surprising for me. Uh, this is not a big issue, ma'am. We'll discuss
This
in
would be the
the
case if you are saying this form. It should be okay.
yes, which you have written. You
Huh.
have just erased it.
Okay.
That's
Just
the situation.
yeah, just send me that in the next doubt session. Just send me the thing.
Yes, ma'am.
Okay, I'll
Yes,
just
yes,
look
ma'am.
into it.
Yeah.
Okay. Then we have the fourth thing, which is the sample proportion. Okay. So what is the sample proportion? It is denoted by SA, which is equal to what?
The condition which we wanted to
Yeah. So
verify
basically,
divided
it
by the
will be
number.
the yeah, it will be the number of xi for which A is true
A is true upon n.
upon n. So if I have to find out the expectation of SA, it would be what?
Probability of A.
Correct. And the variance of SA,
Probability of A into 1 minus probability of A upon n.
hmm, correct. Probability of A into 1 minus probability of A divided by n.
N.
So this is the, sorry, you're saying
Ma'am,
something?
No,
ma'am,
no, no,
I,
anything.
ma'am, I had a doubt, like when to use sigma square as the variance and when to use sigma square by n as a variance. I could not follow.
Yeah, can you repeat yourself?
When to use sigma square as the variance and when to use sigma square by n as a variance.
Sigma square is the population variance, and sigma square by 1 is the expectation of, sorry, the variance of sample mean. Okay, let's continue. So, okay, let's suppose I'm having sample x1, x2 till xn. Okay, so and these are equal to and I need to find out the expectation of the sum of these samples. That means expectation of x1 plus x2 till xn. This will be equal to what?
expectation of x1 plus expectation of x2 until expectation of xn.
Correct. And is there any condition for this? Any?
No, no, ma'am.
No, right? And if I have to find out the variance of their sum of the sample, this will be equal to what?
Variance of x1 plus uh, variance of till until variance of xn, given that they are pairwise independent,
Correct. If,
or IID. We need not check pairwise if it is given IID also, independent or IID.
yeah. So in basically they should be pairwise independent. That's it. Then only we can say the sum of all the sample, the variance of the sample will be equal to their individual variance. Fine.
Ma'am,
Okay.
I'm having over here a doubt.
Ah,
Pairwise means x1 and x2. We check,
they,
multiplication of those expectations. Should we check
ah,
for all the uh, x's like x1?
ah,
So we'll have to check x power n times, right? Actually, with each in total to check if they're pairwise. Every variable is
hmm, hmm, ah.
pairwise. Is that the method? I'm just asking about that.
Yeah,
To
yeah,
check
that's the method. We
pairwise.
have to
Okay,
check
okay.
for all the pairs. Yeah. Okay. Okay. So if I say if my xi's are independent, it means that they are uncorrelated. Correct? Can I say?
Yes, ma'am.
Okay. So can I say reverse, vice versa? If they are uncorrelated, that means they are independent?
No.
No, right? So just remember that.
Not
If my if my xi's are independent, then we can say they are uncorrelated. But we can't say if they are uncorrelated, that doesn't mean that they are independent. Fine?
Yes, ma'am.
Understood? Okay. Now, the last thing was the weak law of large numbers, okay, which is WLNM. So what was this? What is weak law of large number?
Uh, it's
If
like
we need to find out.
similar to Chebyshev's inequality, where we over
Ah,
here we find the deviation from the mean,
correct.
probability of deviation.
So basically, the equation is probability of mod of x bar minus mu. Remember, greater than delta, less than equal to sigma square by n delta square. This is the equation of the weak law of large number. So we are basically what we are finding out. The distance, like the distance between the x bar and the mu. Okay.
Yes, ma'am.
Okay. Okay. So these were some of the formulas, some of the theory part that was there in week 7. Okay. Let's solve some questions. And
Ma'am, here delta is denoted by.
delta is denoted by,
I
delta is
mean,
just the, it's just
yes.
like some quantity. Like, okay. So basically what is WN? We are finding out if my mu is here. Okay. And this is my mu delta and this is my mu minus delta. So we are finding out like what is the distance, like how my sample mean, uh, like how much my sample mean differ by the actual mean of the distribution. So we are finding out that thing. So basically this is my mu, this is my mu delta and mu minus delta, right? So
Okay.
we are what we are finding out, we are finding out if my x bar, if my sample is greater than mu plus delta, okay, that means we are finding out this area, or we are finding out x bar is less than mu minus delta, we are finding out this area, okay. And so basically, if we combine this, we are getting what? My mod of x bar minus mu is greater than delta. That means these thing we are finding out. Understood? Basically, what? Some quantity. Okay.
Yes, ma'am.
Huh. So shall we solve some questions? Is this thing clear? The overall thing? I didn't go that deep. It's fine.
Yes, ma'am. It's fine for me.
Ma'am, I solved this question.
Is my
Variance.
voice breaking up or
Yes, your voice is
Yes, ma'am.
breaking.
Yes, ma'am. Your voice is actually had hung up. I thought it's my internet issue.
No, no, no. Ma'am's voice is
okay?
breaking.
Let's solve this question. Yeah, I think I'm having some net issues, I guess. Now is it fine?
Yes, ma'am. It's fine.
Mm, oh,
Ma'am, option A.
Option A, ma'am. I solved it.
yeah. So how
It is like the sample variance formula, ma'am. No, sorry. Variance of sample mean sigma square by n.
to solve it? So basically, what are the values that we have been given? Yeah. So we need to find out the variance of a sample mean, right? So sample mean is basically what? Sigma square by n.
N.
Now, for the first case, okay. So what is my value of sigma square here?
36.
It is 36. Okay. So the first case is when my sample size is 625. So my sample mean is equal to what? 36 divided by 625, which will be equal to 0.05. Then we will be taking the next case in which my sample size has been decreased to what?
36 upon 64.
That is 64. Okay. So my variance of sample mean will be equal to 36 divided by 64, which will be equal to 0.56. So this question is clear. This was actually simple, not that tough. Is that fine? So this is how you find out the variance of a sample mean. So if you see here, if my sample, if you see what conclusion can you make out? If my sample is decreased, my variance will also, sorry, if my sample size is decreased, my variance will also,
Will
Increase.
all. Hmm. No,
it
no.
will in,
Yes. Yes, yes.
yeah, it will increase. Okay. Hmm. Now, a random sample of size 100 is collected from a population with a standard deviation of 25. Find a lower bound on the probability that the sample mean will be at most 5 units away from the actual mean using the weak law of large numbers. Okay, for this type of questions, now what you do, you just uh, tally out all the values that you have been given. So first of all, what the values you have been given? That is sample size, which is n, which is 100. Okay. Then you have been given the population standard deviation, which is sigma 25. Okay. Now you have to find out the lower bound. So basically, if you remember weak law of large number, they are telling you which bound, upper or lower.
Lower bound.
Yeah. So this is the equation.
Yes, ma'am.
Okay. So basically,
In the
what is
question,
this
I'm
bound?
saying actually.
Yeah, in the question. No, I'm asking about in the
Okay, okay.
equation. Like
Over here, it's upper bound actually.
it's upper bound. So if we have to find out the lower bound, what we would be doing?
1 minus of upper bound.
Correct. So this will be the equation basically. Okay. So now probability of x bar minus mu. What is the value of delta?
1 minus 25 square upon 100 into.
Yeah. What is the value of delta?
Delta would be 5.
Delta would be 5. How? Because we are finding out the lower bound on the probability that the sample mean will be at most 5 units away from the actual mean. That means my difference x bar minus mu should be less than equal to 5. So my delta is equal to what? 5. Okay. So this will be equal to 1 minus sigma square is 25 square divided by n is 100 into what is delta square? 5 5 is the 25. Okay. So if you solve this, you will get 0.75 as the answer. Is it fine? Is the question clear?
Yes,
Yes,
ma'am.
ma'am.
Everyone? Okay. Shall we proceed to the next question then?
Yes, ma'am.
Okay. Am I going too fast? Just if it, just tell me. Okay.
No, ma'am. It's fine.
Okay. Okay. Now, sixth question. A random sample of size 100 is collected from a normal population with mean mu and variance sigma square. Suppose the expected value and the variance of the sample mu is 0.25. Find the value of mu plus 10 sigma. How are you going to solve this?
First we'll find since mu is same, so 50 plus 10 times sigma. So sigma we have to find from sample variance. Sorry, sample mean of variance, which is sigma square by n. We have to equate 0.25 equal to sigma square by n. From there we'll get sigma, and root over sigma will be getting uh, the normal sigma. We'll substitute that over there and we'll get the answer as 100.
So basically sigma square will be what? 0.25 into 5. So my sigma square is 25. Yeah. So basically I got sigma as 5. And mu is 50. My sigma is 5. So mu plus 10 sigma will be equal to 50 plus 10 into 5, which will be 100. Fine?
Yes, ma'am.
Okay. Now let x1 and x2 be two IID random variables with mean mu and variance sigma square. Given below are three different formulation of sample mean. A is x1 plus x2 by 2. B is 0.1 x1. These are some equations. Okay. Now you need to find out the, so you just solve it and tell me the answer. Now, are you guys solving it?
Yes, ma'am. Ma'am, is it one option A?
What about others? Nobody has solved yet.
Ma'am, fourth option.
Fourth option. How did you get fourth option?
No, ma'am, first option. First.
First option. Okay. So basically, the correct answer is variance of A is less than variance of B and it is less than variance of C. How? How did you guys calculated it? Variance of A is equal to what? Variance of x1 plus x2 divided by 2. Correct? Am I audible?
Chup. Yes, ma'am.
Okay. Okay, so this will be variance of x1 plus x2 divided by 2. So now this is a constant term. So if you remember, variance of ax1 plus bx2, this will be equal to what? A1, a variance of x1 plus b square variance of x2, correct? Now for both of this, that means my a value and b value both are what? My 1 by 2. So this will be equal to what? 1 by 2 square variance of x1 plus variance of x2, correct?
Yes,
Yes,
ma'am.
ma'am.
Yes, sir.
Okay. So now this will be equal to what?
Both are same, so twice of.
Yeah, so this will be twice of sigma square, which is equal to sigma square by 2. Similarly, you'll be finding out the variance of B. So what is variance of B?
0.1 square plus 0.9 square, which is 0.82.
Hmm. 0.9 square variance of x2. So this will be equal to 0.82 sigma square. Okay. Now variance of C is basically what? Sigma square only?
Yes, ma'am.
Yeah. So if you see here, my variance of A is sigma square by 2. Variance of B is 0.82 into sigma square, and variance of C is the original sigma square. Right? So that's why
Yeah,
the variance of A, sorry.
ma'am. While calculating variance of A, can we even treat it like sample mean? From there, we derived. Can we derive variance of sample mean, which is sigma square by 2? Oh, sorry, sigma square by n.
By
Over
N.
here, n is 2. Can we say it that way also?
Yeah, it is, we can say that.
Okay, okay.
Because basically, what is my A? A is just the sample mean only. X1 plus x2 divided by 2 is the same thing as x bar. Okay?
Yes, ma'am.
Yeah.
Yeah, okay, yes, ma'am.
So this will be variance of A less than variance of B less than variance of C. Fine. This question is clear?
Ma'am, over here again a small calc in variance of A. Since small a is equal to 1 by 2 for all of them, so it will become sample mean, right?
No,
Can we
sorry, can
say
you come again?
uh, so, in the distribution of A,
Hmm.
like in the form, what is the formula of expectation of A? It is given as small a1 times x1 plus small a2 times x2 until xn, an times xn. Over here, small a is equal to 1 by 2 for all. Like over here, two
Correct.
samples are given.
Hmm.
So it is 1 by 2 is equal to for all of them. So can we say it is sample mean?
Yeah, it is a sample mean. This is basically what? My sample mean only.
Yes, ma'am. Okay, yes, ma'am. I understood. I was just clarifying. Okay, yes.
Huh.
Got it, ma'am.
Okay. So shall we proceed to the next question then?
Yes, ma'am.
Okay. Now, a fair die is rolled 1,000 times. Let x denote the number of times 6 is obtained. Find a bound for the probability that x by 1,000 differs from 1 by 6 by more than 0.2 using Weak law of large number. Solve it and tell me the answer.
Ma'am, could you solve it? I am not able to solve.
Okay. What about others? Okay. Okay, I'm solving it right now. Okay. So the thing is, a fair die is rolled 1,000 times. That means my n is 1,000. Let x denote the number of times 6 is obtained. So x is basically what? That 6 should be there. Now, find the bound for the probability that x by 1,000. So basically, what is my x by 1,000? This is basically my sample mean, right?
How are you saying it, ma'am?
Yes.
Okay. So what is my x? X is the number of times 6 is obtained, right? So I can have different samples. So for the first sample, how many times my 6 obtained? Now, x for x2, for x3, like that. Correct? So, okay. So x is denoting the number of times 6 is obtained. So we are rolling down the dice 1,000 times. So this will go on till how many times? 1,000?
Yes, ma'am. 1,000 times it will go
Yeah.
on.
So this whole thing, the sum is basically the, so I am just dividing this whole thing, the sum of all the samples by 1,000. So this will be what? My sample mean?
Uh, like, why are you summing the all the mean? I'm not able to understand why
Acha, okay,
x
let me,
x ones.
let me just, okay. So first of all, x is denoting what? X is denoting the number of times. I can state that the number of times 6 is obtained in 1,000 tosses. Can I say that?
Yes, ma'am.
Yes, ma'am.
Right?
Of course.
So basically, what will be my x? X is basically x1 plus x2 till x 1,000. Can I say?
Yes, ma'am.
You know, what is my x? It is the number of times 6 is obtained. So x is basically what? For the first toss, for the second toss, till 1,000, like that. So I can sum it up. So that is my x. So if my sum is being divided by 1,000, this will be equal to what?
Yes, ma'am. Mean.
Mean, right?
Yes,
So
ma'am.
that's it. So my
Ma'am,
x by 1,000 is basically my x bar. Fine. This thing is clear. Why this is x bar?
Yes, ma'am.
ma'am, here
Okay.
x1 can be 0, ma'am, also.
Yeah, if if 6 does not occur, if 6, we don't, like 6 is not there in the first row, like that.
Ma'am, here you're adding cos x1 or x2 or x3 in that way. Can we say
We are
in
adding.
thousand times six may occur or not occur? If occurs, like we'll add.
Huh. So what?
Okay,
So
okay.
basically, my xi, like if my each of the sample will be having two cases, right? So if I say, like if I denote 1, if 6 occurs, okay, and I can say 0 otherwise. So I would be having two cases for each of the samples. If 6 occurs, I will denote as 1. If it does not, it will be 0. So I can have different results, right, for each of the tosses, correct? So
Yes, ma'am.
what is
Yes,
my
ma'am.
x? X will be the sum of all the result that has
Successes.
success. You can say that, right? Okay.
Yes,
So,
ma'am.
okay. Now this is basically what? This is a Bernoulli trial. Some, if I say only for one sample, this is for this is Bernoulli actually.
Yes, ma'am.
Yes, ma'am.
Bernoulli
Okay.
with probability 1/6.
So what would be my expectation of one sample? It will be equal to,
1 times 1/6.
it will be 1
1
by
by
6. This is equal to, for Bernoulli, the expectation is basically what? P, and variance is equal to what? PQ, correct? Right?
Yes, ma'am.
Okay. Now, the variance of xi would be equal to,
1/6. into 5 by c.
Correct. So this will be equal to 5 by 36. So for each of the sample, I have my expectation and I have variance, correct?
Yes, ma'am.
Yes, ma'am.
Okay. Now we need to find out the probability that my x by 1000 differs from 1 by 6. So basically, what is my 1 by 6? It is the expectation,
Yes, ma'am.
Yes,
yeah?
ma'am.
So 1 by 6 by more than 0.2. So this will be what? My delta,
Yes, yes, ma'am.
Yes, yes,
है ना?
ma'am.
Okay. So I can write this as probability that my mod of x minus mu is basically 1 by 6 is greater than 0.2. This will be less than equal to sigma square. What is sigma square? 5 by 36 into n is 1000 into delta square, which is 0.2 square. Correct?
Yes, ma'am.
Okay. So if you solve this thing, you will be getting what? 5 by 1440. Then you will be solving something and you will be getting some value here. Is the question clear?
Yes, ma'am.
Everyone?
Yes.
So first of all, in this question, what we did, first of all, we find out the expectation, then we find out the variance. Then after that, we put all the values. Okay. So in the question, we did not had any value of mean. We did not had any value of variance. So from the condition, we find out the value of mean and variance. Then we put it in the formula. Is it fine?
Yes, ma'am.
So
Yes,
how
Okay.
you find the variance
Variance. Okay. For a Bernoulli trial, what is the variance? Formula of variance?
for binomial?
Hmm?
Ma'am, NP into 1 minus P.
That is for binomial, and I'm asking for Bernoulli.
N is equal to 1 over there.
So basically, it will be P into Q. Okay. So in this question, what is my P? P is 1 by 6 and Q is 5 by 6. So this will be 5 by 36. Fine.
Okay.
Hmm. Okay. Now, next question. Let x1, x2 till x6 be IID samples whose distribution has mean 15 and variance 4. Suppose the sample variance is defined as this, where x bar is basically my sample mean. Find the expected value of s square. You have been given the value of mean, you have been given the value of variance. You have the formula of s square. Now find out the expected of s square, which will be equal to what?
4.
4. How?
It's a formula, ma'am.
Yeah, it's a formula. So this is basically what? Summation of xi minus x bar whole square divided by n minus 1, correct? So n is 6. So 6 minus 1 is basically 5. So this is basically my original formula of sample square, sample variance, right? So we know that the expectation of sample variance is equal to sigma square. And sigma square here it is 4. Fine. Is the question clear?
Yes. Ma'am, once could you go to the previous question, ma'am? Over here, mu, we are using it from expectation, right?
Hmm.
Okay, yeah. You can carry on. Okay, thank you.
This question is clear to everyone?
yes, ma'am.
Okay. Then next. Now you have been given another formula, which is this formula of sample variance. Now you need to calculate the
Hello.
Yes.
Ma'am, could you solve this question? Uh, I'm getting a big solution actually.
This will be a little bit big. Okay. What about others? Are you guys solving the question other than Manish?
Yes, ma'am. Trying to solve.
Yes, ma'am.
Trying to solve it. Okay. Okay. So basically, we need to find out the expectation of S square. So what is S square? S square is basically my x1 minus x bar whole square plus x6 minus x bar whole square divided by 6. This is the thing. Now, I 1 by 6, I can take it out. So this will be expectation of summation of xi minus x bar whole square. Can I write it like this?
Yes, ma'am.
Okay. Now this square thing, I'm opening the brackets. So this will be equal to summation of I 1 to 6 xi square plus x bar square minus 2xi x bar, correct?
Yes, ma'am.
Yes, ma'am.
Okay. Now this summation will get inside. So this will be summation of xi square 1 to 6 plus summation of x bar square minus 2 summation of xi x bar. Fine.
Yes, ma'am.
Okay. Now, uh, x bar is basically what? Summation of xi divided by n. So I can write summation of xi equals to n into x bar, right? So I
Yes, ma'am.
can write this as 1 by 6 expectation of summation of I goes 1 to 6 xi square plus this summation. See, for each of the samples, my sample mean will be same, right? So I can write this as 1 by 6 expectation of
Ma'am, your voice is breaking.
x bar square. So this can be written as 1 by 6. Now is it good? Fine.
Yes, ma'am. Now it's clear.
Just a second, let me switch. Now is it fine?
Yes, ma'am.
Okay. So now summation of xi square plus 6x bar square minus. In place of summation of xi, I can write it as nx bar, which is equal to what? 2 into 6 x bar square. This step is clear?
Yes, ma'am.
Okay. Now 1 by 6. So expectation. So this will be expectation of summation of xi square plus 6x bar square minus 12x bar square. Correct? Now I can write this as 1 by 6 expectation of summation of xi square minus 6x square x bar square. Till
Yes,
here is
ma'am.
it fine? Okay. Now I need to find out this value, summation of xi square. So summation of xi square is basically, okay, summation xi square. Okay, let's take expectation inside. So this will be equal to 1 by 6 expectation of xi square plus 12x bar square. Am I audible?
Yes, ma'am. Now you are audible.
Now you are audible, ma'am. We skipped the last step.
Um, Now also my voice is breaking.
Not right now, ma'am.
No, not right.
Oh, okay. So is this step clear? I just took expectation inside the bracket. Fine. Now I need to find out the value of expectation of xi square. If you remember, variance of x is what? Expectation of x square minus expectation of x whole square. Correct?
Yes, ma'am.
Yes, ma'am.
Okay. So in place of x, I have xi. So expectation of xi square is basically what? Variance of xi plus the expectation of xi whole square. Can I write?
Oh, yes, ma'am.
Yes, ma'am.
Okay. So what will be my variance of x according to
It
the
would be
question?
15, I guess. I don't remember. 4.
Mean is 15 and variance is 4. So variance of xi is 4 plus and expectation of xi is 15 whole square. Fine. So this will be equal to 229. Now I need to find out expectation of x bar square. Same. Expectation of x bar square will be equal to variance of x bar plus expectation of x bar whole square. Fine.
Yes, ma'am.
So
Yes, ma'am.
variance of x bar is
4.
how?
No,
Variance of
ma'am.
sample mean is equal to
Square of divided by n.
Sigma square by n.
hmm. So this will be equal to 4 divided by
N, ma'am.
n is 6
6.
plus this will be equal to 15 square because expectation of x bar is equal to mu only. Correct?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now put these all values in this equation. So this will be equal to, so my expectation of s square will be equal to 1 by 6, 229 minus, so this is summing. So this will be 6 into 229 minus 4 by 6 plus 15 square. If you solve this, you will be getting 10 by 3 as the answer.
Ma'am, this level of questions will be given, like in question, any quiz sort of area. Like this is so
Mm,
laborious.
yeah, it's
It's
laborious.
understandable, but uh, through the steps we might miss during a fast pace environment, actually.
Hmm. I don't think so. They would be giving you these type of questions, but just remember how to solve it. That's it.
Okay, okay.
Hmm.
Okay.
So this question is clear. Are the steps clear?
Yes, ma'am.
Yes, ma'am.
Okay. Shall we proceed to the next question then?
Yes, ma'am.
Yes, yes.
So now, a random sample of size 100 is collected from a population P, where P is following a uniform distribution with 0, 20. Find an upper bound on the probability that the sample mean will be at least 2 away from the actual mean using the weak law of large number.
Ma'am, is it 0.083?
Correct. So how do you solve it? It is basically probability of
X bar,
X bar minus mu.
yes, X bar minus mu is greater than 2, which is given, at least 2, is less than or equal to sigma square by n times delta square.
okay. So what is sigma square?
It is b minus a by 12, b minus a whole square by 12, which is 20 square by 12. I have not solved it actually. I've just substituted that way, ma'am. Into 100 into 2 square.
So it will be 400 divided by 12, correct?
Yes,
Into
ma'am. 100
what is
times
delta
4.
square? So
4
this will be 4.
into 100.
If you solve it, you will be getting 1 by 12, which is equal to 0.083 something. Fine?
Ma'am, a small query. I forgot how to, if they ask, if they are not given a delta value, could you just give us a small gist on finding delta value through the question? If there is a question such that included, please don't tell now. I'll just solve and understand.
Uh, like you're telling me if they don't give you this value.
Yes, yes, ma'am. Yeah,
I think
I
they
don't
would be
remember.
giving you this value, or otherwise they would be giving you some situation like that in which you will get to know what is your delta value, or you will be given this value. You will be or else the question might be like this: that this is the unknown value, which is delta, and you would be given this value, which is 1/2, 12, or something like that. So from this thing, you have to find out the delta. So basically, my 1/12 is basically what? Sigma square by n delta square, correct? So you know the sigma square, you know the n. So by equating the values, you will be getting delta square, which is 12 sigma square by n. So like that, like there will be a question like that maybe.
Okay, okay,
So you
ma'am.
can find out like that. So
I
something or the
understand.
other will
Yes,
be
ma'am.
given. Yeah. Okay. Now this is the last question. A business school calculates MBA students' overall program scores using three components: written assignments, group presentation, and case study analysis. The variance of the written assignment scores is 25, the variance of the group presentation score is 40, and the variance of case study analysis is 60. The overall program score is calculated as a weighted average where written assignment contribute 50%, group 30%, case study 20%. Assuming all three scores are mutually uncorrelated, what is the variance of the overall program score?
Who removed, ma'am?
Host only removed, I guess.
Hello, am I audible?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Okay. Sorry, some network issue. Yeah. So this is the question. Did I completed the whole question, the reading of the whole question, or before that I only left?
Yes, ma'am. Exactly. You have completed and you got
Oh,
removed.
okay. Okay. So you understood the question, right? Solve it and tell me the answer.
Ma'am, is it 12.25?
Correct. So how did you solve this?
Uh, it is given that uh, variance is in form of uh, different additions of variance, like sum of variances, and each variance contribution is also given, which is 50%, 30%, 20%, and we take out. I have converted into fractions, sorry, integers, so
Hmm.
0 0.5 and 0 0.3, 0 0.2, and
Correct.
squaring of 0 0.5 square into variance of that written assignments plus the other
So
also
basically, you're
0.3
finding
square.
out 0.5 into the variance of written exam plus 0.3, the variance of group presentation plus 0.2
0.25.
for the case study, right? So this will be equal to 0.5 square into variance of written exam plus 0.3 square into variance of um, group presentation, sorry, group presentation plus 0.2 square variance of case study. So this will whole be equal to 0.25 into 25 plus 0.09 into 40 plus 0.04 into 60. So if you solve all these values, you will be getting 12.25 as the answer. Fine?
Yes, ma'am.
Is it fine to everyone?
Yes, ma'am.
Yes.
Okay. So I guess you got the overall idea how to solve the questions, right? So that was the last question. Is week 7 clear?
Yes, ma'am. Perfect.
Yes, ma'am.
Okay. Was I too fast? I don't know. I think
No, it was fine, I think.
it was fine.
Yes, ma'am.
Yeah,
Ma'am, a small,
hesitating.
a very basic doubts are there in activity questions. Could you,
Tell me.
if possible, could you solve them?
Tell me.
Practice assignment, seventh question. Could you just go there? It's just theoretical doubt, actually.
7 question. Okay, let me see. Which among the following is a random variable? That question?
Yes, ma'am. I feel even variance of a sample mean is also random because it changes. It's not constant, right?
Variance of a sample mean.
Yes, ma'am.
Hmm. Hmm. Which among the following is a random variable?
It's a constant, right?
Well, it's
Because it's sigma square by n, right?
sample means variance of a sample. It should no. How it can be a random variable?
It's just a
What's your
constant.
theory?
I feel since sample mean is random variable, So sample variance of sample mean is also differing uh, based on n. Oh yeah, I understood, ma'am. Okay, sorry, I got I it's clear.
It's
No
clear?
need to explain. Yes, yes, yes.
Okay. Okay. Any other question?
Uh, if possible, that the starting expectation of S square, if you could discuss, it's in week tutorial one actually. Last question. The solution is also given over there.
Tutorial.
Tutorial one. Tutorial one.
Okay.
Last question.
It's the same thing that we have solved now.
Yes. Okay. Now I understood. Over there, if it is n minus one, then it would be sigma square, right?
Correct.
Yes. Yes.
It
I
is
was.
sigma square, and if it's divided by, like, it's divided by n, right? So if we have solved it, we got what? Summation of sigma square, but just without the numbers, just write all the notations. Then you will get n minus 1 sigma square by n.
Yes, ma'am.
Mhm.
I understood, ma'am. It's clear. In the starting, I did not see it was n.
Hmm.
Now I understood it was n minus one was not given. Yes. Clear.
Hmm. Something else?
Ma'am, I had a doubt in week 6 GA. If you could please explain.
Week 6. You didn't get the solution PDF?
Ma'am, for graded assignment, like question number 7, if you could please explain.
7. Let's see. Is going to write a continuous. I think this you have to integrate it, huh? Right?
Which question, ma'am?
Question number 7 of graded assignment 6. Now the page left. Represent. Okay, so the question is, you have been given the joint detail. X is greater than 0, y is greater than equal to 0. You have to find the probability that X is greater than 6 and y is less than equal to 8. So basically, my limit, my x is going from, it is 0 to infinity, right? So here my limit is x going from 6 to infinite, okay? And my y is from 0 to 8, fine? So this is my limit of x and y, fine? Now, if you need to find out the probability that my x, this probability, it will be what? My integrating this value. So first of all, this will be double integration. So this is the integration of y. Y will be from 0 to 8, and for x, it will be 6 to infinite k e raised to the power x plus y. So this will be the solution. So first of all, you need to find out the value of k, and you know that the if you integrate, right? So that means integration of 0 to infinite, 0 to infinite k e raised to the power x plus y will be equal to what? 1. So with this, if you solve this thing, you will get some value of k. So after getting the value of k, put it here and solve the equation. Is it fine? The person who asked me the question,
Yes, ma'am. Yes, ma'am.
is the question clear?
Yes, ma'am. That is clear, but ma'am, how to
Hmm.
find the value of expectation?
Find the value of expectation. Where it is written?
Um,
What your question? This is your 7th question, right?
yes, ma'am.
Fine. Yeah. So where it is not asking any expectation.
Ma'am, it's Ma'am, the expectation like a conditional like x condition y is given 1.5 and it is asking that expectation of x condition y is equal to 1.5. So ma'am, how to find it? I was asking that.
Which one? Which question?
Week 6 graded assignment question number 7.
Yeah, my graded assignment question is this one only. So in that question, they are not asking any conditional value. In your, they are asking conditional value?
Yes, ma'am, expectation of the condition value. Ma'am, should I send it?
Ma'am, maybe, ma'am,
Yeah, since it's a
question
graded,
numbers are different.
yes, ma'am. Since it's a graded assignment, I guess it's different for all.
Okay.
For me, it's different also. Some, it's a similar question for you. They gave me k values x actually.
Okay, because my seventh question is this one. So I don't know what others.
Ma'am, can we leave if the class is over?
Yeah, the class is over. You don't have any doubts on week 7, then you can do for sure.
Okay. Okay. Thank you, ma'am.
Okay, bye. Thank you.
Ma'am, can I show you the question so that you can
Huh.
do the practice?
Yes, just send me the chat box.
Okay, ma'am. Ma'am, I'm unable to like send it in the chat box. Should I present my screen?
Okay, present your screen. Okay, so the joint density function of two random variable x and y is given as this. Find the expectation of conditional distribution and the answer corrected to decimal places. Expectation of x given by equals to 1.5. Expectation conditional distribution. Just a second. So there must be some, there is a formula, right? Summation of fx, what is that formula? Have you guys, like, you have not been taught the expectation of conditional distribution, right?
Uh,
No, right?
no, ma'am, I don't think so. Matlab, I couldn't recall that formula. If it was taught.
Um, okay, like, I'll just check with the question, okay?
Yes, ma'am.
Can you send me this question through on mail or something?
Yeah, ma'am, I can.
Hmm, Just send me a mail. Do you have the mail ID?
No, ma'am, I don't have your mail ID.
You are in the
Sorry, ma'am.
discourse.
Yes, ma'am. I posted
No,
this in Discord also, but I
you
couldn't
have
get.
posted. Did you tag any instructors?
I don't think so I can.
Yeah, just tag it. Just tag any one instructor so that we can see the question, right?
Okay, ma'am.
Hmm. So just tag. So you have this. Just tag this question. Okay. Sorry, this question and tag any instructors. Trainer is there. Swati is there. Okay.
Okay, ma'am.
Hmm.
Thank you, ma'am. The session is over now.
Yeah, yeah. Session is.
Thank you, ma'am.
Bye, everyone.
Bye, ma'am.
Bye.
Thank you.